Let's go. This is for every child that wants to make it one day. Izimbo class and presence of mind is elsewhere. Cinga usuzani afuna kuhle already alisipani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, they the written and focus.
Hi everyone, it's Sihle Bonani again. Welcome back to Basic Chemistry 101. So we are moving on right along. Last time we were talking about the scientific method, if anyone can still remember. That's where chemistry revolves around. So now from that scientific method, we are taking that concept of a law. If you can remember well, we spoke of a law as a concise statement or a mathematical equation about a fundamental relationship or regularity of nature. That was what we said about a law. Now, to try and explain this more, we will talk about a law of conservation of mass. This is our lesson for today. Just a bit of history nje, because everything has history. I don't know if you hated history when you grew up. You can't be doing anything without knowing where it comes from. Now, we talk of our chemistry right now as modern chemistry. Now, when they spoke of modern chemistry, they say it started in the 18th century. Now, the chemists then, when they were doing their research, they started using balances. A balance, it weighs mass. So that's where you get your kgs or your tons and all that stuff. So they started using balances back then. So they weighed mass. Now a mass is what is called what is a mass again? A mass is what is called a quantity of matter. Quantity of matter in a material. So in those 18th century, there was a guy called Antoine Lavoisier. Forgive me if I am pronouncing it wrong. He is not from where I am from, so I might be not familiar with how to pronounce his name. But this guy was a French physicist. He was one of the first people to stress the use of balances in a chemical research. So in a chemical research, he used to weigh the reactants before he does a research, and then he would also weigh the products. So from weighing the reactants and products, that's where he came with the law of conservation of mass. Now, for us to be able to explain what the law of conservation of mass, it was because of this guy, Antoine Lavoisier. He weighed before the reaction and weighed after the reaction. So keep that in mind so that we can be able to continue and explain what a law is. So what he did, he stated the law of mass the law of conservation of mass, as it's stated as the total mass remains constant during a chemical change. This is the law of conservation of mass. Total mass remains constant during a chemical change, which means the mass of the reactants must be equal to the mass of the products. So that's what he did. He did this by the method of combustion, that is burning of substances. He would burn metallic mercury, and then he saw that when you burn a material, some of this material that you are burning, it combines with oxygen. It combines with oxygen to give a different substance. So if you had, let's say, 5 grams of metallic mercury, and then your product is, let's say, 10 grams, the product. So because the mass of the reactants is higher than the mass of the mass of the products, is higher than the mass of the reactants. Therefore, it means the mass of oxygen, which is combined with mercury, is equal to 5 grams as well. So this is what he means. He means mass reactants is equal to mass products. So this is a law, a concise statement. As we said, the mass remains constant. So he's very sure that the mass remains constant, or a mathematical equation, mass of reactants is equal to mass of products. So that is what we mean by a law. That is what he was saying when he tried to explain the law of conservation of mass. So that is what we are trying to talk about today. And let's do just one example to try and illustrate the use of this law. I'll try to put up this question that I have. This was one of the question papers from my university. So the question is, or reads as follows: exactly 6.64 grams of sodium hydrogen carbonate was added to a solution of acetic acid weighing 24.46 grams. Carbon dioxide was released into the atmosphere during the reaction. After the reaction, the contents of the reaction vessel were weighed and found to be 27.6 grams. There's 3 questions there, but the first 2 are not where we are right now. The last question would be, use the law of conservation of mass to determine the mass of carbon dioxide given off during the reaction. So this is the law of conservation of mass. So it means mass reactants is equal to mass products. So what they are saying there, they added 6.64 grams of sodium hydrogen carbonate to a solution of 24.46 grams of acetic acid. And then this gave us a total mass of 27.60 gram of what was left in the reaction vessel. Now, if we read the question or the statement correctly, it tells us that carbon dioxide was released into the atmosphere. So this is what is left. So for us to get the total mass of a reactant, it means you must add the mass of carbon dioxide. The mass of carbon dioxide plus this mass would be equal to this. So for us to get the mass of carbon dioxide, so it would be this 6.64 gram plus 24.46 equals 27.60 plus mass of carbon dioxide. So carbon dioxide would be equal to 6.64 minus plus 24.46 minus 27.60. Then you do your maths, you get your final answer. That is the law of conservation of mass and the application of it. So this is the start of your chemistry and understanding that what is a law, a concise statement. Concise, the mass remains constant during a chemical reaction. That is the law of conservation of mass, or a mathematical expression. Mass reactants is equal to mass products, about a fundamental relationship or a regularity of nature. So from there we have defined what is the law of conservation of mass, and that is I don't have a calculator. You'll calculate this, and then you have a you'll calculate this, and then you tell us what you get in the comments below, and also you subscribe to the channel, and we meet in the next video for some more. Thank you very much. My name is Sihle Bonani. This is Basic Chemistry 101. Booyaka!